Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are going to discuss about the chapter chemical bonding. In this session we are going to see the introduction part of this chapter. Okay. We have learned in the previous classes that there are around 118 elements so far discovered, isn't it? Most of these elements do not occur free but as compounds. Out of these 118 elements, very few elements they exist in the free form as it is in the earth crust. But many of them they do not occur in the free state, but they occur as compounds. What is the reason that most elements do not occur free? Why they are occurring in the compound state? Why they are not occurring free? Why do elements combine with other elements to form compounds? Instead of being free, why these all elements are combining together and forming these many compounds? The answer to both these questions lies in the reactivity of the elements. So if you understand the reactivity of elements, then you can get answer for these questions. Why elements are not being free? Why elements are combining together to form compounds? For this all, the reason is the reactivity of elements. Elements that occur free are relatively non-reactive. They do not react easily with other elements and so occur freely. Elements that do not occur free are relatively more reactive. So this is the reason. Some elements they occur in the free state in the nature. Those elements said to be less reactive or least reactive. They do not combine with other chemicals and even they do not combine themselves also. That is why they occur in the free form in the nature. But many of the elements they do not occur free in the nature. This is because those elements are relatively more reactive. As reactive, immediately they combine with other chemicals and hence they exist in the form of compounds. Okay? They react easily with other elements and so occur as compounds. When elements react with other elements, they form chemical bonds. See here, some elements they have combined together. I think it is shown here carbon combined with hydrogen atoms. So, as these two elements are reactive elements, they combine together and formed a compound here. So when elements combine together while forming compounds, certain attraction occurs between the elements. Those attractions are called chemical bonds. See, these blue lines represent here chemical bonds between the atoms. Because of this chemical bond formation, they will be together and hence it is called a altogether a compound. So compounds are formed because of the chemical bonds formation between the elements. In 1704, Isaac Newton proposed that atoms attach to each other by some force. In 1819, Berzelius proposed a theory of elements combining due to the electronegative and electropositive character of the combining atoms. So the chemical bonding which we are studying nowadays. Before that, these all scientists they have proposed their theories. In 17th century, in the 18th century, Isaac Newton proposed that atoms attach to each other by some force. He expected that. In 1819 again, Berzelius proposed that a theory of elements combining these elements are combining due to certain electronegative and electropositive forces or character of the elements. By the middle of 19th century, various scientists developed the theory of valency. According to this theory, compounds have joined owing to an attraction of positive and negative poles of the charges. So, by coming to 19th century, different scientists they have proposed different theories based upon the valency. So, according to this theory, atoms with opposite charges are attracted together and hence they are forming a compound. It was in 1916 Jean Louis developed a concept in which two atoms share 1 to 6 electrons, thus forming a bond. That same year, Cosell put forward a theory similar to that of Lewis. So he stated that bonds are formed by the transfer of electrons between the atoms. The bonds were due to attractive forces. So here, Lewis and Cosell, they explained how atoms combine together to form compounds. Lewis proposed that atoms, they share electrons between them to form bond. At the same time, Cosell proposed that atoms, they transfer electrons from one to another, and hence they create some attraction. Because of that, chemical bonds are formed. Okay, so about these two we are going to learn in clear in further classes about how elements are sharing electrons, how elements are transferring electrons between them. So first let us see the reasons for the non-reactivity of noble gases. At the starting we told out of these 118 elements known till date, some of them are less reactive comparatively and they do not participate in the chemical bond formations we told. What is the reason for the non-reactivity of these elements? We call those elements as noble gases, isn't it? Around 6 to 7 elements are there. Those elements, they do not combine with any other elements and even they do not combine themselves also. That is why they exist in the free atomic form and even all are gases. So why these noble gases are non-reactive? What is the reason for this? Let us understand that first. So if you know the electronic configurations of these elements, then we can understand the reason for their non-reactivity. Noble gases are monoatomic in nature. Monoatomic in the sense single atoms, because they do not combine themselves also. They will be in the individual atomic form. So they do not form molecules either with own atoms or react chemically with other element. So why? Why it is not happening? In order to answer the above question, let us study the electronic configuration of the noble gases as illustrated here in the table. See here, the electronic configurations of noble gases are mentioned. Observe these ones. If you observe, helium electronic configuration is 2 because atomic number is 2. If you see for remaining elements, neon 2, 8, argon 2, 8, 8, krypton. So if you observe the electronic configurations of these all elements, we can observe this. Except helium, remaining all elements, they have 8 electrons in their valence shell, isn't it? And helium, it is having only one shell that is completely filled with 2 electrons. Okay, let us see the explanation for this. We notice that the exception of helium means except helium because it is having only one shell that is completely filled with 2 electrons. Except helium, remaining all other noble gases have 8 electrons in their valence shell. Thus, we can say that helium has duplet configuration in its valence shell, whereas all other noble gases have octet configuration in their valence shells. Octet means having 8 electrons in the valence shell. That is called octet. Octa means 8 we know. Duplet configuration. Helium has duplet configuration means it has 2 electrons configuration in its valence shell. It has only one shell that is filled with 2 electrons. That's called duplet configuration. See, it is helium. It has only 2 electrons in the first shell. It is completely filled. If we see any other noble gas like neon and other elements, so they have 8 electrons in their valence shell. This is called octet configuration. This is a duplet configuration. So a duplet or an octet configuration of electrons in the valence shell is most stable, and any atom having this configuration will be in the minimum state of energy or maximum state of stability. We can understand one thing here: energy and stability both are quite opposite. If an element, if it is having greater energy, that will be least stable. If an atom or element, if it is observed with the greater stability, that contains least energy, minimum energy. So it is observed The atoms with duplet configuration or octet configuration, they have greater stability and a minimum state of energy. So why do atoms combine? We know that noble gases do not enter into any chemical reaction due to their stable duplet or octet configuration in their outermost shells. So hence they are chemically inactive. This assumption was made by Cosel and Lewis independently in 1916. So about these two scientists just now we have seen. One scientist Cosel, he proposed that elements combine together by transferring electrons. And at the same time, Lewis also independently he proposed that atoms combine together by sharing 2 to 6 electrons in between them. Same scientists, they have proposed why these elements are being active also. Because the elements they do not have octet or duplet configuration are being unstable and hence they are being reactive. And the elements with the duplet or octet configuration are being more stable and hence they are called noble gases. With the exception of noble gases, atoms of all elements have 1 to 7 electrons in their outermost shell. Yes, except these elements, remaining all elements they do not have octet or duplet. That means they may having 1 to 7 electrons in their outermost shell. Thus, the electron configuration of outermost shell of these elements is incomplete because it should have either 2 electrons or 8 electrons in its valence shell. If it is only one shell, 2 electrons should be. If it is more than one shell, that atom should have 8 electrons in the outermost shell. But the remaining all elements they do not have these many. So we can say that is incomplete configuration, outermost shell configuration. Hence, they are unstable and have a tendency to attain stability by attaining the stable configuration. So those elements which do not have this duplet or octet configuration are not stable elements. They are unstable we can say. So these unstable elements also will tend to get that stable configuration either by gaining or losing or sharing electrons. So in other words, atoms of the same element or different elements combine with one another so that they attain duplet or octet configuration and hence they become stable. So the elements which do not have octet or duplet configuration, they are unstable, means being reactive. These elements they will combine with the atoms of same atom, same element, or atoms of these different elements. They combine and hence they attain their octet or duplet configuration. Consider sodium, whose atomic number is 11 and its configuration is 2, 8, 1. And let us consider one more atom, chlorine also. Both are here unstable, isn't it? Because they do not have 8 electrons in outermost shell. If you see for sodium, there is only 1 electron in its outermost shell. Whereas if you observe chlorine, it has 7 electrons in outermost shell. Both are not having octet configuration or duplet. So they are unstable. When sodium and chlorine are brought together, so being both are reactive, when these two brought together, sodium loses this one electron, which is gained by chlorine. As a result, Na plus and Cl minus are formed, thus making themselves stable. So what is happening here? Sodium is having only one electron in its valence shell, hence it is not stable. So by losing that one electron, sodium will become Na plus ion with configuration 2, 8. If you observe here, the configuration now it is having octet, means 8 electrons in its outermost shell, hence it becomes stable. At the same time, the electron lost by sodium is gained by chlorine and it became Cl minus ion, and thus it getting octet configuration. Okay, in that way, by losing and sharing of electrons, both of these atoms became stable. So it is happening here. Sodium losing one electron, chlorine gaining one electron, so that they became stable. Further stability is correlated to energy. Yes, the stability is also correlated with energy as we told. As a system with less energy is more stable. During a chemical reaction, the reactants lose energy and the resulting product has less energy. So here we discussed about sodium and chlorine. Both are more reactive as they are having unstable electron configuration. So they are unstable and having more energy. So when they are losing and gaining electrons, while getting this octet configuration, they lose energy and hence they become least energetic. The product of these two will become least energetic. As the product has less energy, it is more stable. So during a chemical reaction, stability can also be achieved by lowering the energy. Okay, we can thus conclude that the cause of chemical reaction is to attain stability. This is the main reason for in the chemical reactions we say. Atoms combine chemically to attain stability, to become more stable or least energetic. This is the reason for the complete chemical reactions. Now let us see octet rule. The atoms tend to acquire 8 electrons in their outermost shell, except hydrogen, lithium, beryllium, because they attain nearest stable configuration, duplet configuration. Okay, in order to attain stable state, this is called octet rule. So all the elements except noble gases, they will try to attain 8 electrons in their outermost shell and hence they become more stable. This attaining 8 electrons in the outermost shell is called octet rule. Now let us see here some Lewis symbols of the elements. So for explaining this chemical reactivity of elements, Lewis has proposed these symbols. So chemical bonding mainly depends on the number of electrons present in the outermost energy level of the atoms. These electrons are termed as valence electrons. So the electrons present in the outermost shell of an atom are called valence electrons. The electron configuration of sodium, for example, if you see its atomic number is 11 and its configuration will be 2, 8, 1. And that of sulfur, if you see its atomic number is 16 and its configuration will be 2, 8, 6. Thus we can say sodium has only one valence electron, isn't it? It has only one valence electron. Whereas if you see sulfur, it has 6 valence electrons. Now, these can be represented by dot structures. If we see sodium, as it is having only one valence electron, first its symbol is written and then a dot. It is represented around its symbol, which is representing the valence electrons of sodium. As sodium has only one valence electron, it is represented with one dot. If we see for sodium, as we told, there are 6 valence electrons. So the symbol of sulfur is written and around it 6 dots are representing 6 electrons. Okay, these are called Lewis symbols. So what we did? The valence electrons in an atom are shown in terms of Lewis symbols. To write the Lewis symbol for an element, we write down its symbol surrounded by the number of dots or crosses which are equal to the number of valence electrons. Paired and unpaired valence electrons are also indicated. The Lewis symbols for hydrogen, sodium, oxygen and chlorine may be written as this. See here the symbols of these elements. If we see for hydrogen, what is the number of valence electrons for hydrogen? 1. There is only one electron. So first as the symbol of hydrogen is written and a dot is kept around its symbol as representing its valence electron. In the similar way sodium, and if we see for nitrogen, we know the atomic number of nitrogen is 7 and its configuration will be 2, 5. So if it is 2, 5, how many valence electrons will be there? 5 valence electrons. So the symbol of nitrogen is written and 5 dots are kept which are representing these valence electrons. Similarly for oxygen 6 electrons and for chlorine 7 electrons. If you observe here These are paired electrons. This is unpaired electron. So paired and unpaired electrons all are represented around the symbol of that element as dots, which are representing valence electrons of that atom. Okay, by this we can say the stability of the atom also. If it has 8 electrons, then it is a stable element. If it is having less than 8 electrons in its outermost shell, it is said to be an unstable or more energetic element that will participate in the chemical bond formation to attain the stability. Got it? These are Lewis dot symbols. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates on recorded videos.